Good day to you all. Welcome to the 7th lecture of Magnetic Compass online lecture series. In this lecture, we learn about ship's induced magnetism and different induced magnet which affect the ship's compass. Let's begin. Let's start with induced magnet. What is induced magnet? An induced magnet is a magnetic material that becomes magnet only when it is placed within a magnetic field. Unlike a permanent magnet, an induced magnet loses most of or all of its magnetism once it is removed from the field. Induced magnets are only attracted by other magnets, they are not repelled. Induced magnet loses most or all of their magnetism when they are removed from the magnetic field itself. Right? Here in the picture we can see a induced magnet, a permanent magnet which is surrounded by some ferromagnetic material, right, or the iron filling. This iron filling in the image become induced when they are near the bar magnet, but it will lose their magnetic property when the bar magnet is removed. From the previous slides, we have already known that these soft iron are susceptible to the induced magnetism, and these soft iron are called high permeability material. Why? These high permeability material are relatively easy to become magnetized when placed in a magnetic field. However, it will quickly loses its magnetism when inducing field is removed. To understand the inducing magnetism better, we need to remember an important note. I want you to write down this important note in your notebook. Soft iron can only become induced if it is aligned with the inducing field, whereas the hard iron retains all its magnetism in all heading. Thus, an induced magnetism ship's heading plays a vital role. We'll see that bit in the following slides. Right? On board ship, there are thousands of soft iron. The following soft iron are considered to affect the magnetic compass most. The first one is fore and aft continuous HSI. This fore and aft continuous HSI runs forward and aft direction. Athwart ship continuous horizontal soft iron. This athwart ship continuous horizontal soft iron or HSI runs on the port and starboard side direction. Vertical soft iron with a pole above or below the compass. So this vertical soft iron runs on a top to bottom direction or bottom to top direction, and VSI forward or above the compass. This VSI vertical soft iron remains normally at the back side of the compass, because most of our superstructure including funnel, it remains on the back side of our and on the astern side of our compass. So these are the four important horizontal soft iron which will have impact on our magnetic compass. We'll see what are those impacts. Let's start with the fore and aft continuous horizontal soft iron induced by H. The fore and aft continuous HSI is induced by Z, and it is considered to pass to the compass position. To understand this effect of fore and aft continuous HSI, we need to keep in mind one important thing, that this soft iron has only length. The soft iron is an one-dimensional object. We have to assume that, and we have to assume that it doesn't have any depth or breadth, and it will help us to understand the soft iron better. Let us see a ship. So we have got a ship over here, and in that ship we have got a soft iron which runs from forward to aft direction, and we have, as usual, it is placed at any place on the earth surface. It will have some impact of the magnetic lines of force. So these magnetic lines of force are entering on the astern of that ship and coming out from that ship. So as we know, when the magnetic lines of force entering to a magnetic substance, it will create blue pole. So that's why here it is a blue pole is created, and here when it is entering from that ship, it is creating red pole at the forward. when the ship changes its direction, so suppose it is on 00 degree heading, and when the ship changes direction from 00 degree heading to 180 degree heading, what will happen? It will, the horizontal soft iron, here also it is running from forward top direction, and but magnetic lines of force is now, and instead of entering at the astern, now it is entering at the forward direction, right? So here in this case, in the forward side it will create blue pole, and in this case here we have got red pole. So this type of soft iron, we call it as fully induced soft iron, and this fully induced soft iron will affect our compass needle, right? Now we have got a now that ship has heading has been changed. Now the ship heading is suppose 045 degree. So with the 045 degree, our horizontal soft iron is also changes its heading. Now here we have got some magnetic lines of force, and here we have got horizontal soft iron. As magnetic lines of force is entering in this direction, so at the astern of that ship we'll have blue pole, and here we'll have red pole. And here for that ship, when the ship's heading is 2 to 5, that time at the forward of the ship will have blue pole, and here we'll have red pole. Let's see what happens. So here the magnetic lines of force is entering on that side, here it is creating blue pole, and here forward it is creating blue pole, and here when the vessel heading is 045, it is creating red pole at the forward, and when the vessel heading is 2 to 5 degree, that time it is creating red pole at the stern. Why? Because lines of force is entering here in this direction. So when the vessel magnetic lines of force is entering in that direction, it will create blue pole, and in the side the magnetic lines of force is emitting, in that side it will create red pole. Now let's see what happens. So this type of induced soft iron, we call it as partially induced soft iron, and we call it partial induction, right? Now let's see what happens when the vessel course is 090 degree, that time, and when the vessel course is 270 degree, what will happen for the horizontal soft iron, continuous horizontal soft iron, 4.5 continuous horizontal soft iron. So here we see that as this 4.5 continuous horizontal soft iron doesn't have any breadth or length, so it will not have any kind of induction at all, right? So here you see, so as it is not having any breadth or depth, it will not have any induction at all. And for this heading also, 270 heading also, it will not having any kind of induction at all, right? So we call it not induced at all, right? So we can say that when the ship's head changes, the red pole of the horizontal soft iron also changes, right? So here you see in this picture we have got a ship which is heading 000 degree, and due to the induction by H, we have got red pole at the stern and blue pole at the stern and red pole at the forward. So this horizontal soft iron is fully induced, and it will be completely aligned with the ship's magnetic needle. It will not have any kind of deviation. However, the directive force can increase and decrease. In that case, what will happen? The horizontal soft iron is having blue pole at the forward and red pole at the stern. In that case, this horizontal soft iron is fully aligned with the magnetic meridian and magnetic lines of force. So that's why it is not having any kind of like deviation. Now here you see our magnetic needle is supposed to be on that direction, right? On 00 degree direction. However, now it is partially induced, that partially induced horizontal soft iron red pole will deflect that magnetic needle and it will have some deviation. In that case, it will have some deviation as well, right? Whereas when the vessel course is 090 degree or 270 degree, there will not be no induced magnetism at all, so it will not have any uh, induction, and therefore there will not be any kind of deviation at all, right? Let us see what happens with the adhesive continuous HSI. This adhesive continuous horizontal soft iron is induced by H and is considered to pass to the compass position, right? So here we see once the vessel course is 090 degree or 270 degree, that time it will create blue pole on the starboard side, right, when the vessel course is 090 degree, and red pole on the port side because our lines of force is entering on the starboard side and exiting on the port side, right? So in that case, our magnetic needle is also in this direction, so this magnetic needle will align with the adhesive continuous HSI and it will not have any kind of deviation. Wherever when the vessel heading changes to 045 degree, that time it will be partially induced, and this partially induced adhesive HSI will have red pole on that side and blue pole on that side. That red pole will deflect the compass needle and it will have some deviation, and when the vessel course is 00 degree or 180 degree, it will not have any kind of deviation at all, right? Let us recap a important concept. The direction of Z. We know that in the northern hemisphere the vertical component of total magnetic force will enter from top, and in the southern hemisphere the vertical component of total magnetic force will enter from the keel, right? So that's why we'll have different pole in different magnetic hemisphere. Let's see what happens to the VSI, the vertical soft iron, right? So this vertical soft iron is induced by jet, and top of the vertical soft iron is usually considered to be the abaft, right, and level of the compass position, right? When the vessel is on the northern magnetic hemisphere, that time this vertical soft iron for or above the compass, it will have a blue pole at the top, and when the vessel on the southern magnetic hemisphere, it will have a red pole on the top side, right, and it will have some impact on our compass needle, right? However, when the vessel is on the magnetic equator, that time the Z force is 0, so vessel will not be induced at all by Z force, and it will not have any impact on our compass needle. Now let us see what happens with a vertical soft iron with a pole above or below the compass. So this vertical soft iron induced by jet acts to the compass position and will not cause any deviation if the vessel is upright, right? So for this type of VSI will not have any kind of impact when the vessel is upright. So same. So in the northern hemisphere, once our lines of force is entering from top side, it will create a blue pole at the deck or at the monkey island, and when the vessel is on the southern hemisphere, as the magnetic lines of force is entering from the keel, so it will create a blue pole at the keel, right? But this vertical soft iron will not have any kind of impact on our compass needle. So let us make a table for forces causing the deviation. We have got paramagnetic force, induced magnetic force. So for all of them, let us create a table. So we see that we have got P force, which acts fore and aft direction, right? And regardless of ship's head, it will not change its magnetic pole, and it will have some impact. Q force, it will act in the other shape direction regardless, and it is a permanent magnetic force. Regardless of ship's head, it will not change its magnetic pole and it will have some impact. The R force acts in deck to kill or kill to deck direction, and the vessel, when the vessel is upright, there won't be any kind of impact on our magnetic needle. Fore and aft continuous HSI induced by H acts in a fore and aft direction, and when the vessel is on the 045 degree or 2 to 5 degree course, that time that means when the fore and aft continuous HSI is partially induced, that time it will have some impact. Athwart ship continuous HSI acts in the athwart ship direction, and same like fore and aft continuous HSI, when it is partially induced, it will have some impact on our compass needle. Vertical soft iron induced by jet forward or above the compass acts in a forward and aft direction, and vertical soft iron with the pole above or below the compass acts in deck to kill or kill to deck direction. When the vessel is upright, there will not be any deviation at all. I hope this table will help you to understand your magnetic compass better, and see you on the next class. Thank you very much.